Okay, I'll be presenting my screen. So in that, so in the previous class, we were studying about the assignment problem, right? So in the assignment problem, we were supposed to find the that is the if we are given with a balanced problem, assignment problem, and we completed, that is we found the what is the cost which is there, for total cost which is there when we will be assigning that to each and every machines which are there. So here today we are going to see about the unbalanced assignment problem. Okay, so this is the problem about this problem which we will be having. We are having at about 5 columns and 4 rows, right? So when we will be checking what is the balanced assignment problem, that is when the number of rows which is there equal to the number of columns, then we will be calling that as the balanced one. But here it is an unbalanced problem. Okay, so we need to convert that to a balanced one. So for which we can, that is we did in the transportation problem, right? We will be adding the dummy row or dummy column according to the thing which is necessary. So here just we will be adding as the number of rows 4, we need to make it to 5. So for which we will be adding a row which is containing 0 elements. This is how the dummy row which we will be adding. Now our matrix is in 5 by 5 matrix. Okay. So here D5 is added. So we will be having all the zeros in that particular row, and because of which we are our 4 by 5 matrix which is there, that has changed to 5 by 5. Now it is a balanced one. Now we need to start with the procedure. So here, there we will be finding the row reduction as well as column reduction. As we have that is the row reduction, that is we need to do here, as we have included one of the dummy rows which is there, then we are supposed to find the row reduction, but we should not find the column reduction, because already we are having zeros in each and every column which is there. Okay, so this is the row reduction which we will be making. So after finding the row reduction, what we were supposed to do, we need to draw a line such that it will be covering all the zeros which are there. So minimum number of lines we need to draw based on this. So for which we will be making, that is we will be drawing the line in E as well as last, and in addition to there is a 0 at the starting, right? So we need to have a strike out the first column also. In addition to, when we will be striking out all the things, we will be left with 2 more zeros in the second row. So we will be striking out that too. Okay, now all the zeros which are there in the matrix that are covered by minimum number of lines. Now we need to cross verify. So how much is the order of the matrix? 5 by 5. So now the order of the matrix, which is equal to the number of lines drawn, then we can tell that it has reached the optimal value. But if it is not so, we need to proceed further. So here when we will be checking, only 4 lines are there, right? So if it is having only 4 lines, what we were supposed to do, we need to find the other thing, right? So select the least uncovered element which is there. So here, what is the uncovered least element? we can see like 2 is the uncovered, sorry, 1 is also there, right? So we can have 1 as the least. So because of which, what are all the intersection points, we need to add it. In all other places, we need to subtract it. Okay, so that is the method we have sticked on with, right? So uncovered element we will be adding. So after making it, what we will be getting? We will be getting another set of elements, right? So now again we need to repeat the procedure. What is the procedure? We need to make the column reduction, row reduction which is there. Then what we were supposed to do? We need to find what are all the subtracted, that is what are all the elements which are there, and based on which we need to cover the elements. Okay, so when we will be making again, that is we will be covering the elements, here we can see 5 strikeouts are there, or else the 5 number of lines are there. The order of the matrix is also 5. So because of which the optimality condition has reached. So because we will be assigning the jobs. So for which we need to assign the jobs to the machine. Okay, so wherever we need to check with what all the zeros which are there. Okay, so when we will be checking in the first row, we will be choosing the first one. Okay, first is 0 and we will be boxing it. And again in the second row, we will be choosing the second one. Third row, we will be having only 1. In the fourth row, when we will be checking, that is in all other previous things, what we did, the leftmost 0 we will be considering, the rightmost we will be leaving. But here when we will be checking, we will be having 2 zeros in 4, not 2, 3 zeros are there, right? But what is the condition? That is, in the first column as well as second column and also in the fifth column, already a box is there. Okay, so we need to see to that whichever column which is there, which is not circled, or else it is not boxed. Okay, so in the fourth column, D is unboxed. So we will be choosing that as the thing to be dictated and to be marked. And in D5, that is in the dummy row, again we can see like, now what are all the columns which have marked? A, B, D as well as E. All the things are marked except C. So in C, we can see another 0 is there. So we will be marking that as the case. Okay. So that is how we will be checking out the zeros, and based on which, what is the first, that is the starting element which is there in that particular position. Okay. We will be considering that. So 5 is the first position which is there. Second is B2. So in B2, what is the value which is there? B2, this 5, right? So again, in C5. In C5, 0 might be the value because we have added the dummy row. And D4, what is the value which is there at first? D4, 2 is the value. Then in E3, we'll be having 3 as the value. So all such values need to be plotted over here. So after making it, we need to assign the job for the machines. So A, B, C, D, all such things will be noted here with the cost. And after making it, we need to make the summation of the cost. So the summation of the cost is 15. So that is the final total cost which we have reached. Okay. So when we are getting a matrix with the that is when it is unbalanced, then we were supposed to balance it by adding the dummy row or else the dummy column. Here only 4 rows are there, so we will be adding a dummy row. After making the dummy row, what we need to do, match with we'll be checking with the row-wise reduction. But column-wise reduction is not needed because we have added dummy row and already we are having one value which is 0 in each and every column. So we are not supposed to do the column-wise reduction when we are adding a dummy row. So afterwards, we'll be marking the striking out the zero, that is the zeros with minimum number of lines. So when we will be making here the order of the matrix, which is not equal to the number of lines which are drawn. So we'll be telling like it is not optimal. So what we are supposed to do, we need to take the least possible element from here, which is uncovered, and we need to make addition with the intersection points, and also what are all the uncovered elements, we need to make a subtraction. So after making it, we'll be getting some values. So with that, we need to again strike out the zeros with minimum number of lines. So when we'll be checking here, we'll be getting 5 as the number of lines drawn, which is equal to the order of the matrix. If so, what we are supposed to do, we need to box the zeros. So when we'll be boxing the zeros, at first we can see 0, 0 and E. 0 will be marked. So remaining things are C and D. So accordingly, we need to mark for 4 and 5. So after marking it, we need to take what is the initial elements and we need to assign the cost for it. So after assigning the cost, we need to make a summation of the total cost, which is the total cost of the thing. Okay. So now this is another example which you are going to do. Okay. So as like the previous one, this is the same where we'll be having the problem is likewise, that is in a plant layout, 4 different machines M1, M2, M3 and M4 are to be erected in a machine's shop. There are vacant areas A, B, C, D and E. Because of the limited space, machine M2 cannot be erected at area C and machine M4 cannot be erected at area E. So we will be having that blank over there. The cost of erection of machines is given in the table. So this is the assignment problem which is given where area and machine are there. In M2C as well as M4A, we'll be having a blank. So we'll be assigning the highest cost. Hence, we'll be calling it as H. As we'll be making the high cost, we'll be assuming it as H. Okay. So other than that, whatever thing which we have done before, we need to proceed as such. Do it. If any doubt, ask me. Yes, Ansel, tell me, ma. Any doubt? Ansel, you raised your hand, it seems.
No, ma'am, without knowing it got touched, ma'am.
Ah, okay. Anyone completed now? So I'll give 5 more minutes, complete it, and I'll be sharing what is the answer which is there. Whether you completed, ma? Yes. This is the way in which we need to approach. So at first we'll be having the hash in both the cases, after which we need to make a row reduction. Then we are not going for the column reduction as we have added the dummy row. So after which what we need to do, we need to cover all the things. But when we'll be covering, only 4 is there, but 5 is the order of the matrix. So we need to, in the intersection places, we need to add what is the least uncovered element, and all of the other places, other uncovered elements will be subtracted from there. And after making it, again, we need to process the same. And when we will be checking here the number of rows, which is equal to the order of the matrix. So we can tell that this is the optimal assignment of the machines. So we need to make the optimal assignment now. So for which we need to box the zeros. So first we will be boxing the 3. Afterwards, we will be saying like only C and D are the columns which is not boxed with. So we need to prefer that for M4 as well as D5 row. And afterwards, we need to make the optimal solution. So for which M1, M2, M3, M4, D5. So in that, what is the respective place where we'll be having? So the erection cost based on the box one, we need to take the starting initial value which is there. So when we'll be getting 44110. So the total erection cost which is equal to rupees 10. Okay, we need to sum it all the thing. So that is how we need to make the optimal solution. Have you got it? Okay. So we know now the assignment problem with the balanced assignment problem as well as unbalanced assignment problem. Okay. Next class we can see about the integer programming problem. Okay, ma. Thank you. Any query, ma? No, right?